Chapter 7. The Botts-Jenkins Methodology. ARIMA modeling is commonly applied to time series analysis and control. ARIMA is an autoregressive integrated moving average. Let's use annual data to forecast by using ARIMA model. First, let's check the seasonal effects of the data. The result clearly indicates that the series contains trend component. Also, it is evident from the time charts that the data is not stationary and the series is not constant around some fixed value. The graph shows that the data have no seasonal and non-stationary. After that, we will plot the ACF and PACF graph by using SPSS. From the ACF and PACF plot, it is more conclusive that the series is not stationary. ACF plot shows ACF values are relatively large and decline rather slowly to 0 and then increase slowly at negative side after late 11. From PACF plot, there is significantly large spike at late 1, followed by smaller other spike other than late 1. Again, it shows that the data is non-stationary. Since our data is not stationary, we will differentiate the data. The ACF graph after first differencing and the PACF graph after first differencing. This ACF and PACF graph shows that the data quite stationary. To confirm the stationary of the data, we try to plot the line graph. The graph shows that the data stay not stationary yet. Then we can improve it by differencing for the second time. ACF graph after second differencing for the second time, and PACF graph after we differencing for the second time. Now, the ACF and PACF graph shows that the data is more stationary. Let's check again by plotting the graph line. By seeing this graph, we can say now the data is stationary since the series constants around some fixed value. After the data becomes stationary, we are now to estimate the possible model by use the ACF and PACF graph of second differencing. The spike for MA is late 1 and possible late 3, thus the Q is maybe 1 or 2. Then the spike for AR is possible late 1 and late 4, thus the P is maybe 1 or 2. Since we had differences twice, so the D is equal to 2. Based on the information we get, the following four models have been identified, which are ARIMA 121, ARIMA 221, ARIMA 122, and ARIMA 222. Next, let's make the hypothesis. H0 equal to errors are random, white noise, and H1 equal to the error are non-randoms, not white noise.
Created using Powtoon.